Okay, welcome to the class. So today is our first lessons with AdMath. So in AdMath, there is 10 chapters here. So we will start from chapter by chapters. Normally, the school teacher will teach chapters by chapter, follow the sequence also lah. So if you have your AdMath textbook, you can see that our first chapter is about functions. Okay, and then it followed by quadratic function, system equation, and so on. So for the first chapter, function is actually the chapter which is doable, and quite often it will come out in the SPM questions. Okay, so for our style in the tuitions here, okay, normally we will start with teaching first, and then we will discuss some of the questions, and of course you need to try some questions. So I will expect you to ask questions whenever you don't understand, and I expect you can try to follow in the class. So during the class, maybe some of the questions is easy for you and you can finish the questions very quick. Then never mind, you do it, and then sometimes we need to wait for those weaker students, let them finish first, then we discuss. Okay, sometimes if you feel like the questions is very confusing for you and very difficult for you, please ask questions. You can ask either unmute yourself or you can ask by the chat, through the chat there. If you don't ask, then I don't really know whether you can do or not lah, because now it's online, right? I can't really see what you do there. Okay, so this is something that you need to make sure you can follow. And yeah, asking question is important thing, and doing the homework is important thing also. Okay, so I expect to have a more interactive one. So the interaction doesn't mean you have to unmute yourself and talk lah. Okay, if you are shy, then please you can type in the chat. Okay, so please stop me also if I'm going too fast, or if I'm going too slow and you feel bored, please let me know also. Okay, any problem so far for this one? No, I take the silence as no. Okay, good. Okay, so thank you for reply. Okay, if there's no problem, then we start with the first part. Okay, in your first chapter, which is called function. Okay, if you still remember what you have learned in Form 1, Form 2, Form 3, you most probably will come across some formula. Let's say the area is equals to pi r squared. Area of circle is equals to pi r squared. Okay, when we have a formula like this, this is actually a function. Okay, so all the formula is actually kind of a function. So what does a function means here? Function, you can imagine, is like a machine. Okay, let's say we have a machine like this, and then this machine, you need to put some input, and then it will produce something, right? Okay, and then the process of processing the input and then produce the output, this process is a function. So we have a certain formula. If you imagine there is a machine there, okay, the machine will produce exactly the same item every time, right? Okay, so there must be a formula inside the machine for it to be function. Okay, so function is actually like a formula to use the same process to produce something. Okay, so use the same process to produce something, that is a formula. So let's say if this machine is doing +2, okay, so no matter what I put in, let's say I put in 2, and then it will do the same process, it will always +2 for you, then the output will be 4. Okay, so if my input is 5 here, so it will do the same process +2, and then your output will be 5 + 2, 7. Okay, so every time you do the same process, that one we call the functions. So very important elements here is we will have an input, we will have a formula, and then we will have output. Okay, these 3 items, it will form a functions here. Okay, so normally it won't be so cartoon one in your syllabus. Okay, you will see your textbook, it will write something like this one. For a function, we can represent it by using the diagram like this one, or you will see something like this, the graph, and then have a few dots here. We can represent the function by this one also, or else we can represent the functions by something like this. It will written in the bracket forms. Okay, so how do we differentiate them and how do we call them? Okay, so for the first one, if you have these two overview diagram like this one, okay, let's say for the equation just now, +2, right, the process, if I put in 2, I will get my outcome 4. If I put in 5, I will get my outcome 7. Okay, so for the first circle here, it will represent your object, or it will represent your input, or it will represent your domain. Okay, so whenever you see all these names, object, input, domain are all in the first circle. So the output, this one will be the image. If it is object, then it will be image here as the product. Okay, input, then it will be output. This is one pair. Domain, then it will be codomain. Okay, and then the 2 is linked to 4. So we will draw a line to represent the relationship. 5 linked to 7, okay, then the line represent their relationship. That means the 2 is linked with 4, the 5 is linked to 7. So we don't use the word link, but we use the word map. Okay, so we say that the 2 is mapped to 4. Okay, 5 is mapped to 7, or the object is mapped to the image. Okay, and so on. So the 2, 5 here, it is object, input, or we call domain. And then the output here, we call it image, output, or the codomain. And then their relationship in the middle here, we call it a function. So the +2 here is actually a function. Okay. So if we write it normally, we will say, oh, this is X, and then this is Y. When we want to write their relationship, then we will say that Y is actually equals to X plus 2. So X value here plus 2, it will be equals to Y. You will get Y. Easy, huh? So if I have something like this, okay, this pattern we see later. Okay, if I have something like this, 2 circle, okay, if I have this one 16, if I have this one 4, for example, okay, and their relationship is actually square root. Okay, square root. What do I say? Okay, square root, 2 outside. Okay, so if we do square root for 16, in your calculator, it will tell you it is positive 4, right? But we know that if we do square root, we will get positive and negative answer, right? Because the opposite way, 4 squared, you will get 16. Negative 4 squared, you will get 16 also, right? So when we do square root of 16, you are getting actually 4 and negative 4. And when we do square root of 4, you are getting actually 2 and negative 2. So the 16 can be to this and to this. Same also for 4 can be to these two. So the 16 can be mapped to 2 value. The 4 can be mapped to 2 value. Their relationship is square root. Okay, so if the first one is X, this one is Y, then we can say that when we do Y will be equals to square root of X. Okay, so you will see different pattern here, huh? Okay, so if you see that the first overview link to the second overview, the first overview map to the second overview with single line, like this one, or their item is like this, then we say this is one-to-one relation. If we have these two overview, and then their relationship is like this, like the second one, one number mapped to two different number, then we say that this is one-to-many relation. If I have something like this, two overview, okay, and then two number mapped to one number like this one, then we say this one is many to one relation. if we have this one, but one number mapped to two number here, and also at the same time, two number mapped to a same number. This one, 2 to 1 here. Okay, and then in the first case here, it is like 1 to 2 here. So 1 to 2 and 2 to 1 exist at the same time. So we say that this is many to many relation. Okay, so there are 4 types of relation here. This is type of relation between the object and also the image. Okay, can you write down this one somewhere in your notebook first? Can I give you like 5 minutes to write it down? The question will ask what is the type of the relation. Then you will need to know how to write. Okay, when it asks about type of relation, then there's 4 choice only for you. 1 to 1, many to 1, 1 to many, or many to many. Okay, take some time to write it down. Okay, so far, if you have any questions, please ask. Yeah. Okay, let me know when you finish writing for these 4 items. Okay, done. Okay, so out of these 4 types of the relation, how do we know that whether it can be a function or not? Okay, when we want to define whether something is a function, that means every time when we have the input, it must have an output, right? And then you can produce only one product by using all your materials, right? So that means when it is able to produce only one product, then it will be a function. So for example, like this one to many. So you put in one thing, but it produced 2 items. So this one cannot be a function. This one, not a function. Okay, many to many also not a function because you have this one. You put in one ingredient, but it produced 2 items at the same time. So this one is not a function as well. Okay, so the definition for the function is the relation can only be a function if each object has only one image. Okay, function when the relation I should write like this. I write a complete sentence for you because sometimes it will ask you to explain whether something is a function or not. If it asks about the reason, then you will need to write the relation is a function or not a function, not function. Okay, because each object has only one image. Why I keep spelling wrong? Okay, if it is a function, then that means each object produce only one image, has only one image. If it is not a function, that means the object has more than one image. This one is for function. If it is a function, then this will be the reason. Okay. If it is not a function, then you can say the objects has more than one image. Okay, I highlight it with different color. If it is not a function, then your reason will be the green one here. Okay, so in your concept, if you put in one ingredient and then it produces one product, then that means it will be a function. If you put in multiple product and then it produces one item, that one will be a function as well. Okay, but if it is the other way around, you put in one ingredient but it produces more than one product, then it is not a function. Okay, easy. Okay, another way to test whether it is a function or not, we will use vertical line test. Okay, vertical line test means, okay, when you have a graph like this one, okay, straight line, I want to know whether this line is a function or not. This line normally we will have equation, right? If you still remember what you have learned in Form 3, y equals to mx plus c, right? So every line we plot on the graph, it will have a formula for it, right? It will have a function for it. Let's say this one, y equals to 2x plus 2. Okay, this is the equation, or we call it, this is a function for the graph, right? So we want to determine whether this is a function or not. Then we use a vertical line test. Vertical line test means you draw a vertical line, okay, and then you move around this vertical line. If this vertical line cross the graph at only one point, that means it is a function. Okay, so this line, this graph will be a function. What if I have the graph like this, a U-shaped graph like this? Try to guess whether it is a function or not. You use the vertical line test. Yes, so okay, because when we move around this one, okay, move around the vertical line, it always cross the graph at only one point. Okay, so this is a function also. Okay, what if I have the graph like this? Wait, like this. Okay, we do the vertical line test. Will it be a function? No. Okay, so this one is not a function because it crossed the graph at 2 points. Okay, and then for the first one and the second one, they cross the graph at 1 point only. So this one will be a function, and then this also a function, then this is not a function. Okay, no problem so far. So let's see some of the questions here. Okay, for this one, exercise 1 here. Okay, determine whether each of the following relation is a function or not, and then give your reason. Okay, example here given. Okay, you have 1 map to A, 2 map to B, 3 map to C, 4 map to C, and no one map to D. Okay, this relation is a function because each object has only one image. Okay, because you produce only one product. One ingredient produce one product. Multiple ingredient produce one product. As long as you produce one product, produce one image, then it will be a function. Okay, so for this one, question number 1, is it a function? Then we will need to check whether they produce only one product. Okay, so you can see here, one ingredient, but it produces 2 product, right? So 2 is mapped to 6 and 8. So this one is not a function. Not a function because object 2, okay, has 2 different image. If you're lazy to remember this kind of thing, then you can use a standard sentence, the standard sentence just now, okay? Because the object has more than one image, okay? Or else you want to be specific, then you write like this, object 2 has 2 different image. Can I? Okay, so simple one, So question number 2, will it be a function? Yes, correct. So reason is the same like the example here. Okay, this relation is a function because each object has only one image. Okay, so I think this one have no problem. Okay, and then next one, exercise 2. Okay, when we have the graph, the question asks us to determine whether each of the following graph is a function or not, and then give your reason. So when we have a graph like this, we do vertical line test, as what we learned just now. Okay, we draw a vertical line. So if we draw a vertical line, this one has 2 images at the same time. So that means this is not a function. The reason will be object has more than one image. Okay, so not a function because the object has more than one image. Okay, so this one also the same thing. You draw vertical line test, you have 2 intersection point here. So this is not a function also because the object has more than one image. Can I? So besides writing number and doing calculations in Form 4, Form 5 maths, sometimes it will ask you to give reason also. So you need to justify your answer. So certain sentence like this one, standard one, you better memorize it. Okay, easier for you to answer the questions. The reason always the same. Okay, so for question number 3, do vertical line test. So this one will be a function because no matter where you move the vertical line, you will have only one intersection point. For number 4, vertical line test, you have 2 intersection point. So this is not a function. This one, vertical line test, only one intersection point each time. Okay, so this one is a function. Can I? Should have no problem. Okay, and then next part, we will see these words, domain, codomain, and also the range. Okay, as what I introduced just now. Okay, domain is actually the object, that means the x value. Codomain, that means the output, okay, the y value. Okay, how about the range? Okay, there is some difference here. Okay, domain contains the object only. Codomains contains the image and the non-images. Okay, images and non-images means here, if you have 1 map to 4, so the one involved in the mapping here, we call it object. So our object here will be 1, 2, and 3. Okay, object here will be 1, 2, and 3. Okay, and the object mapped to a number, right? So the number that being mapped here, which is 4, 8, and 12 here, we call these 3 items as image. So our images will be equals to 4, 8, and 12. Okay, the one left alone here, the 6 and 10, we call it non-image because it doesn't map with any number. Okay, and then everything in this set Q here, okay, we call them codomain. Okay, so this whole thing, this whole circle, we call it domain, and then this whole circle of the item here, we call it codomain. So we will write domain as 1, 2, and 3, and then codomain as 4, 6, 8, 10, and 12. Okay, if you notice here, when I write them in a group, I will use this bracket, the twisting bracket, closing bracket like this also. These indicate that they are in a group. Okay, and then the element inside the group here, the member inside the group here, we will write it as the number, comma, and then the second member, comma, the third member. Okay, if you put the bracket like that, that means all of them are in a group. All right, so let's another one. range, range contains the images only. So image here, or we say it is range. Range. Okay, so now 3 keywords are domain, codomain, and range. Domain is everything that map to someone else. Okay, codomain is the image and the non-image. Range is the image only, the one involved in the mapping only. Okay, so now try to take some time to write this one, write this answer. It is better if you have a notebook to write, or else you can write it on a piece of paper. Okay, try to differentiate the domain, codomain, and the range here. Okay, we take 1 minute to get it done. 30 seconds left. Can? Okay. Okay, so what will be the answer for question number 1 here? What will be the domain here? Yeah, correct. 7, 5, -5. The sequence doesn't matter. Even though you write like -5, 5, 7, or 5, -5, 7, all also okay. Okay, open bracket, 7, 5, -5. Okay, how about the codomain? Correct? 49, 30, 25, and 24. Then how about the range? More or less the same thing like codomain, but it is involved only the images. Yep, correct. 49 and 25. Easy, huh? Okay, so number 2, domain will be like what you do just now, those map only, right? So it will be 4, 3, 2, -3, -4. And then codomain will be everyone also in set H. So 16, 12, 9, 8, and 4. And then the range, those who are map only. So 16, 9, and also 4. Okay? Okay. Just now I say you have different way to represent your item, right? Okay, we learned already the 2 circle like this one. Okay, we can actually map our object and the image by using different method. Okay, next one, we call it a set notation. Set notation, that means we write them in pair. For example, I take this one as an example, 7 map to 49, right? So set notation, we will write it in this way, open the twisting bracket, and then bracket 7, 49. And then comma again. Next relation is 5 to 25, right? Then we write like this. The third item is -5 to 25. and then close bracket. Okay, if we write in set notation, that means we couldn't map and we couldn't write the non-images. We write only the object and also the image. Okay, if it's in a set notation. Okay, try again. If we have something like this one, okay, so our set notation will be, why do I put equal? No need to put equal, because you don't have anything equals to. Okay, second set, we have 4 to 16, 3 to 9, and so on. So our set notation will be like this: twisting bracket, normal bracket, 4, 16, close bracket, comma, another normal bracket, 3 map to 9, right? So 3, 9, and then another pair will be 2, 4, and then another pair will be negative 3, 9, and then the last one will be negative 4, 16. Close bracket, close twisting bracket. This one we call it set notation. Okay, so from here we can only identify the object and the images. So the codomain will be all this number, this one, this one, this one are the codomain or the range. And then this one, okay, yellow color, 7, 5, and negative 5 will be the object, or we say domain. Okay, so this is one of the way to map it. Another one is like graph. So graph, we have two different kind of data, if you still remember. Okay, one is discrete data, another one is continuous data. Okay, if it is discrete data, that means very clear-cut number, like blood group. Okay, you have A, B, AB, or O only. So it is very clear-cut. There is no gray area in between. Like number of people, it's very clear-cut one. One person, 2 people, 3, 4, 5 is very clear-cut. We don't have like 1.5 a person. So there's no gray area. Okay, that one is discrete. If it is discrete data, your graph will be something like this. It will plot like this one with your object on your horizontal line. For example, if I take also the first example here, you have 7, 5, and negative 5. So this one you arrange from small number to big number. So negative 5, and then 5, 7. Don't need to follow the scale, because this is object, individual object. It is not continuous data. It is not continuous number. Okay, and then the image here will be 1, 2, 3, 4. You have 4 number, right? So from small to big number, so 24, 25, 30, 49. So your codomain will be the vertical line. Domain will be the horizontal line. Then we map it by put the dot. Okay, let's say here your 7 is mapped to 49. So 7 mapped to 49, you put a dot here. That means it has some relationship between the 7 and 49. Second one is 5 to 25. So 5 mapped to 25, you put another dot here. Negative 5 mapped to 25 also, so another dot here. So from here you can see the domain will be negative 5, 5, 7. And then the codomain will be all the number here, 24, 25, 30, and 49. And then the range, or you can write image, depends on the questions. Okay, the image will be those with dot only. So the 25 with dot, right? 49 with dot, right? Okay, so range will be 25 and 49 only. Okay, so for here, this one, okay, if you have questions like this, set notation, right? Okay, so the domain will be all the object, so it will be this one, 1, 2, 3, and 4. Domain 1, 2, 3, 4. Codomain will be the pair beside it. Okay, A, B, and A, C, right? So if you see here, this one is repeated, right? Okay, since it is repeated, you don't need to write it twice, because it is the same thing, AA. So you write A, B, and C only. Okay, so same thing also for the range here. it will be this one, right? A, B, A, and C. Okay, and it is repeated also. So don't need to write the repeated one. So A, B, and C only. Unless the question say like 1 to A1, and then 2B, 3A2. If it label with A1, A2 like that, then it will be two different items. Then you will need to write A1 and then A2. You get what I mean? By this question, it didn't say it is A1, A2, right? So you don't need to be specific like this one. So the repeated one, you don't need to write. So A, B, C only. Okay. Okay, let's see this one. Set notation, question number 4 here. What will be the domain? Can you tell me? What will be the domain? Correct. A, B, C, D. So here, A, B, C, and D. What will be the codomain? Yeah, correct. PQ. Because PPP is repeating, no need to write. How about the range? Yep, correct. PQ also. Okay. Okay, next one. Discrete data. Like this one, dot, 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 one. Okay. By referring to the site here. Okay, what are the domain here? Yep, correct. It is -1, 0, and 2. -1, 0, and 2. Okay, what are the codomain here? Okay, correct. -1, 0, and 8. Then how about the range? Yep, correct. Same as the codomain. -1, 0, and 8. Easy, Yay! Can Ooh. So same case also for this one, so I skip. Okay, it's the same concept. Domain is the horizontal one, codomain is the vertical one, and then the range will be the vertical but with dot. All right. Okay, and then next one, continuous data, right? Okay, this one is important also because in a lot of the question it will ask, especially in chapter 2 or 3, but you need to know the concept lah. So continuous data is actually like a curve. So when you have a curve graph or something like that, okay, domain means the x value. So let's say if I say that the domain is this one to this one, so it will like draw from this line, like this line to this line only. Okay, if you draw like this to this only, from this line to this line only, okay, the value on the x here, let's say this is 2 to 5. Impossible 2 to 5 there. Okay, let's say this is 1 to 5 here. So we say that this space here is the domain. So the domain is actually, if this is x value, if this is y value, so the domain will be 1 to 5. Okay, 1 to 5. And if the horizontal one, maximum point here, let's say 10, and then this one, let's say 7. Okay, so the codomain will be the y value, right? Will be the vertical range here. So you can see here, this one, because it starts from this point, and then the maximum is on 10 here. Okay, so we say that the codomain will be from 7 to 10. So codomain, and the range also the same, right? Because are all map. Here dot 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 dot. A lot of the dot, then you can form a line, right? So you can see that here actually got a lot of dot here. So that means that between 7 to 10 are all mapped. So we can say the codomain is actually same with the range. So the codomain or the range, it will be 7 to 10. So 7, then this symbol less than or equals to y, and then less than or equals to 10. Okay, so the domain will be the horizontal horizontal value, and then the codomain will be the vertical value like that. Okay, so if I have a graph like this one, line graph also, okay, make it bigger. If I have something like this, okay, and then this value here is -2, this value here is +5, and then this value here is 7, then this value is 5. Okay, in your opinion, what will be the domain? Let's say this is y, this is x. What will be the domain? Try to guess. Domain, okay. Me example here on top. Hey. Yep, the domain will be horizontal one. So it will be this value to this value. Oops. This one is the domain. So you write -2, this value x and 5. Okay, then how about the codomain? This is a difficult part. How about the codomain or the range? The range will be, you see the vertical one. It is actually from what value to what value? My graph is this one, this line. As long as it is line, that means there will be dotted, there will be something mapped to something along this line in order. Yeah, correct. 0 to 7. Wow, very good. So 0, then this one, y, and then 7. Okay, this is very important because always come out in the exam, the shape like this one. In first chapter, in this chapter, it will ask also, what is the range of this function? Okay, if you have the graph like this one, if let's say this is 2, okay, it can be y equals to 2x minus 2, for example. I don't know whether correct or not. 7, 5, no, 7 over 5. 7 over 5 minus 2. So this will be the equation for this line. And then since it is like flipping up, right? So it is actually modulus graph like this. Okay. So the question will ask, what is the range for this equation? Range for modulus 7 over 5x minus 2. Okay. So range, that means the y value start from 0 to 7. So the range will be 0 and then y 7. Okay. So far so good, Okay. Now we come to go for some calculations. Okay. Calculation is very easy only. Don't be scared of all these items here. You see like very complicated. It's actually very easy one. Okay. So the question will say like this one. Find the image or evaluate or find the value. Okay. So when you see these keywords, find the image, evaluate, and so on. Okay, that means we need to solve the equation. Let's say the questions tell us that there is a function, f stand for function. It can be G also, it can be H also, it can be any alphabets there. Okay, and then it bracket with something. Okay, when it bracket with something, it can be like bracket Y also. It can be bracket any alphabet also. Okay, when it bracket like this one, that means the F here stand for the function, the G here stand for the function, and then the X here stand for the object. The Y here is the object also. Okay, let's say if the first one, that means we have these two items. The object is X, so this is set X. Okay, and then the relation between them is F. Okay, and then the final product is Fx. Okay, this one means like this lah. Okay, so it can write it as f dot dot x, and then with the arrow, it means that the function or the relation, this equation, it means that this equation is, let's say I have x2, x power 2. Okay, so that means the relation here is power 2. Okay, or else it can write like this also, f with bracket then equals to, okay, x squared. That means the formula or the equation for the object and the image is x to the power of 2. So let's say if I have the image here, x equals to 2, so the fx will be equals to 2 power 2 because the object is 2. The x value here is 2. So I replace the x here with 2. So the fx will be equals to 2 power 2. So the fx will be equals to 4. So that means it will map to 4. Okay, it looks complicated, but it's actually simple. When you see the equation, you replace the object with the number they want. Okay, so for example, first equation here, it gives you fx equals to 3x plus 2, where x equals to 5. So you need to find the fx, right? Question asking, find the image. That means find the fx. Okay, so what you write is fx equals to 3x plus 2. Okay, fx, where the x is 5, right? So f5, replace the x with 5. X5 will be equals to 3, 5 plus 2. So it will be f5 equals to 15 plus 2. So you will get 7. Okay, if you don't write this one with 5, can also, it is correct also. You can write also like this one, fx equals to 3x plus 2, and then fx equals to, gantikan, replace the x here with 5. So 3, 5 plus 2, so 15 plus 2, 17. Okay, normally this kind of question will be 1 to 2 marks, maximum 2 marks only. So if the question write 2 marks there, that means you need to show the working. This part will be the working. It worth 1 marks. Final answer worth for 1 mark. Can Okay, so let's say if you have second one like this one, fx equals to 3x minus 2 over 2. So your working will be, repeat again, fx equals to 3x minus 2 over 2. Okay, so x is equals to 4, right? So you replace it with 4. 3, 4 minus 2 over 2. So 12 minus 2 over 2. So 10 over 2. So you get 5. Okay, easy, huh? Okay, you try on your own for a few questions here. Okay, these 3 questions, question number 3 to 5. Okay, tell me the answer once you get it. can use your calculator to help you to calculate. Form 4, Form 5, you need to be very good with your calculator. Need the example. Okay, example here. So quick. Okay, good. Okay, so let's see this one. Okay, maintain it as this size. If you haven't finished, then you can try. Okay, so first one, hx equals to 6 over -3 plus 8. Show at least the working like this. So you will get -2 plus 8. -2 plus 8, right? So, okay. 6 divided by -3, so -2 plus 8. So it will become 6, Okay, check your working, see which part you got it wrong. Okay, then second one, fx equals to, replace the x with 2. So at least you show this one, 2 -2 squared plus 3 -2 minus 4. So if you're scared you make mistake, then you do step by steps. -2 squared, you get 4. 4 times 2, you get 8. First part here, you will get 8. Okay, plus 3 times -2, so you get -6 here, minus 4. Okay, then you solve it with your calculator, you should get -2 here, number 4. Okay, okay, then number 5 here, hx equals to x plus 5 over x minus 1. Okay, so you will have hx equals to 3 plus 5, you might 3 plus 5 over 3 minus 1. So you get 8 over 2. So final answer 4. Okay. No problem, Still easy, Okay. Then we go for the next part, Okay. The questions can be like this, but same concept. Okay, if you see the question, we see the example first. It is given that fx equals to 2x minus 5. Find the object. When you say find the object, that means the object is x, right? So find the x when the image is 1. Image refers to the y or the fx. That means the final answer just now. Okay, just now we have the x value. Okay, the answer we get is the image. This is image. Image. This is object. Okay, when the question say find the object, that means you need to do the reverse. Okay, so for this one, you have fx equals to 2x minus 5. Find the object when the image is 1. So that means fx equals to 2x minus 5. The image is 1. That means the fx here is 1. So 1 equals to 2x minus 5. And then do the algebra, find the value for x. Can So for example, this one, the working, you will need to write fx equals to x plus 3. Okay, find the object also when the image is 7. So that means 7 equals to x plus 3. At least you show this one, you will get 1 mark. If the question is 2 marks, okay, then do the algebra. 7 minus 3 equals to x. So 4 equals to x. You can leave your answer in this way, or you write it x equals to 4. Can also. Both are accepted, yeah? 1 mark as the final answer. Okay? Depends on your school teacher's requirement. If your school teacher emphasize very much on you must put the x in front, then you will need to change it, change the positions, write it as x equals to 4. Can I? Okay, you try these few questions, number 2 to number 5. Can see number 2 to number 5. Okay, let me know if you have any problem with this one. Let me know the answer once you get it also. Very easy. Okay. Got the answer for number 2 already. Okay. So here you write fx equals to 3x minus 10, and then 5 equals to 3x minus 10. So 5 plus 10 equals to 3x, 15 equals to 3x, x equals to 15 over 3, so 5. Okay, let me know if my answer is wrong. Sometimes I do mistake also. So please be alert and check my answer as well. If my answer is different from yours, okay? Don't believe 100% on teacher. Sometimes you need to, you need to think and see whether what the teacher say is logical or not. Okay, if something doesn't make sense to you, remember to ask and discuss with the teacher. Same also for other subject and also with your school teacher. Okay, everyone can have different opinion, but you need to discuss nicely with the person who tell you something or what. That's the way of learning. And let me know the answer once you get it. Oh, so fast, huh? Okay. Okay, let's check the answer. I think Sarah also got the answer already, huh? Okay. Let's try checking. Okay, so now you have fx equals to x plus 4 over 2. Okay, image is 6. So 6 equals to x plus 4 over 2. 12 equals to x plus 4. So x will be equals to 12 minus the 4. So you get 8. Okay, so next one, fx equals to x plus 8 over x. Then it says that x doesn't equal to 0. Okay, don't panic about this one. It is just saying that this equation, the bottom value cannot be equal to 0 only. Okay, so it is not part of the equation. So you don't need to continue to write here x not equal to 0. It is not part of the equation. So you just let it, and bear in mind that if you get the final answer x equals to 0, it is not accepted. Okay, so now image is 3. So 3 equals to x plus 8 over x. So move the x over there. 3x equals to x plus 8. So 2x equals to 8. And then you get x equals to 4. All right. Okay, number 5. You have fx equals to x plus 1 over x minus 1. Image is 5. So 5 equals to x plus 1 over x minus 1. So 5 x minus 1 equals to x plus 1. Then you expand it. 5x minus 5 equals to x plus 1. And then 5x minus x, I move the x over there. I move the 5 to the other side. So 1 plus 6. So 4x equals to y6, 5. 4x equals to 6. So x equals to 6 over 4. Simplify it. So x equals to 3 over 2. My writing, no more enough space. Okay, let me move a bit here. Okay, not encouraged to write like this in the exam, or else you can do like this. Okay, put an arrow to the side. Okay, if there's not enough space, put the arrow to the side. Okay, and then write at the side. Or else you can also put a line like this one, and then you continue at the side. Okay, x equals to 6 over 4. X equals to 3 over 2. Okay, doesn't matter if you want to do the indication, the hashtag at the side or not. Okay, it is okay if you leave it like this, or you do like, or if you do like this one, can also. Can okay, this one, question number 6. Okay, try. Okay, got the answer already. Using the function notation, express f in terms of x. Function notation is this one. The bracket thingy. So you start with fx equals to function notation. This is set notation. Sorry. Function notation, that means the function fx, like just now, not this one. This one, you can either write it with the arrow, this one, f dot dot x, this one, arrow, or fx bracket equals to something, function notation. That means you need to find out their relationship. How can the 1 become 1? How can the 5 become 0.2? How can the h become 0.1? This one is harder to define lah. Okay, how can the 20 become 0.05? Okay, you can try to make them become fractions so that you can compare what is their relationship between the 1 and 1, 5 to 0.2, 20 to 0.05. Because if I see the number like this one, 5 and 0.2, it seems like not so related. So if the decimal cannot give you any hints, then we try to change it to some other form, like fractions, like percentage sometime. Then we see whether can link them together or not. Their relationship can be plus, minus, times, divide, or it can be power, or it can be square root. It can be times that only you plus something. Okay, as long as you can find out their relationship. For part A, your answer should be in this format, fx equals to something, where it should be the equation between the set P and set Q. Power -1. Correct. Okay. X power -1. Or else you can write 1 over, can also. Or if you write fx equals to 1 over x, can also. Because the 0.2 here is actually 1 over 5, right? This one is actually 1 over 20, right? This one is actually 1 over 1, right? So when you over the object, you will get the final answer there. So you can either write fx equals to x to the power of -1, or you can write fx equals to 1 over x. Okay. Okay, next one, part B. Find the value for h. That means you have the image, want to find the object. So you do whatever like just now. The fx is equals to 0.1. So what will be the value for h? Yeah, correct, 10. So part B, if you write fx equals to x minus 1, so 0.1 equals to x power -1. So when you do the reverse power, right? Okay, or else you change this one. If this one is very confused for you, then you can always change also 1 over x. Or else if this one is something makes sense to you, you can imagine that if it is x power 3, let's say 0.1 is x power 3, when you do the reverse, you do the cube root, right? So this one also the same. If you want to maintain it as the power -1 here, then you do the root, but root -1. Okay, press in your calculator. This one you can get it from your calculator with this symbol. Okay, if your teacher teach you how to use a calculator when you're in form 3, not KS3, form 3. Okay, you use this symbol, press -1 and then this button and then the 0.1. Okay, you shall get the x answer. Okay, or else if you don't know how to press this one in your calculator, okay, you can do 0.1 equals to 1 over x. So the x will be equal to 1 over 0.1. 1 over 0.1. So you will get x equals to 10. Okay, so there's different method for you to write. Yeah, the answer is 10. Okay, for C, if set P represents all the whole numbers, does every object has its image? If set P is whole number, any whole number, okay, will all the objects has the image? Numbers are whole numbers, it includes negative number, 0, and also positive number. Negative number, negative number, 0, and also positive numbers. That means the question is asking if 1 over negative number, 1 over 0, 1 over positive number, will all of these numbers will have image? Zero count as whole number as well. Yeah, the answer is no, yes. So if you try to press the 1 over 0 in your calculator, it will say maths error, right? Or invalid. Okay, so 1 over 0, you wouldn't get a value. It is undefined. So the answer is no. Okay, see, the answer is no because write something about the 0, because the image of 0 is undefined. Okay, so you cannot take any number over 0. We cannot divide 0. When we divide 0, it's actually undefined. You couldn't find the answer. Okay. Okay, no problem. Then we still have some time, like 10 minutes only. We try something a little bit difficult here. Okay, but it shouldn't be a problem for two of you lah. You answer quite fast here. Okay, so little bit more difficult only. Okay, you see this modulus thingy, okay, this modulus thingy means when you have like modulus -2, you will need to make it become a +2. Okay, so that means that the modulus here, the original answer of the modulus, it can be a positive number or a negative number. Okay, so when you have something like this, fx equals to this equation, and then you have this one, modulus, modulus, if you have modulus 2x minus 3, and then it says that find the object when the image is 7. So that means your final answer is 7 here, but inside the modulus here, it can be a +7 or a -7, right? So we will write like this one, 2x minus 3 equals to -7, or 2x minus 3 equals to 7. In the exam, you not necessarily have to write the or lah. You can just write a comma there, okay? 2x minus 3 equals to -7, comma, 2x minus 3 equals to +7. And then you solve it, you will get 2 sets of the answer. Okay, so these are the possible values of x. Okay, if another clue is here. If you see the questions, if the question use plural or bahasa Melayu, nilai, that means the answer will be more than one answer. Okay, so find the values of x that means your answer should be more than 1. Okay, in this case, it will be 2 answers for the questions. Okay, let's see another example. If I have something like this, fx equals to 3x. Find the objects when the fx is equal to 12. So fx equals to modulus 3x. Okay, and then it is equal to 12, right? So that means the 3x can be positive 12. The 3x can be negative 12 as well. Okay, put a comma in the middle. So here x will be equals to 4, x will be equals to negative 4. So these two will be the final answer. Okay, depends on your school teacher also whether they are very specific or not. Some of the teacher might ask you to combine all the answer, like you need to write x is equals to negative 4 and 4. Or else some of the school teacher will ask you to write x is equals to negative 4 or 4. Okay, depends on your school teacher. What is your school teacher's pattern? But normally in SPM, if you can show your answer until this step, separate one like this, you will get full marks already. Okay. Okay, so let's try this one. Can see or not? These 4 questions can finish in like 5 minutes or not? Should be okay, huh? Okay, we try. Get it done in 5 minutes. Okay. Yeah. Number 2. Okay, you got the answer already, huh? So 3 equals 3 equals to x minus 2. Negative 3 equals to x minus 2. Okay, so x will be equals to 5. And then this one, x will be equals to negative 1. Okay, 5 and negative 1. Correct? Negative 3 and 2. So this one, fx equals to modulus 2x plus 1. And then 5 equals to 2x plus 1. Negative 5 equals to 2x plus 1. So 2x equals to 2x equals to 4, x equals to 2, and then this one 2x equals to negative 6, x equals to negative 3. Okay, I move it up, make it bigger. 7, negative 2. Yep. View. Okay, good. Okay, fx equals to modulus 2x minus 5 modulus. So 2x minus 5 equals to 9. 2x minus 5 equals to negative 9. Doesn't matter you write the negative first or the positive first. Comma in the middle. 2x equals to 14. X equals to 7. 2x equals to negative 4. X equals to negative 2. Last one. It should be fraction. The final answer. Yep. Correct. Okay. So fx equals to modulus 3x minus 1 over 2, and then 6 equals to 3x minus 1 over 2, and negative 6 equals to 3x minus 1 over 2. Okay, so 12 equals to 3x minus 1. What do I say just now? I said correcting, oh, I don't know what do I say already. 12 equals to 3x minus 1, and then 13 equals to 3x, and then x equals to 13 over 3. Next one, negative 12 equals to 3x minus 1. Then move it over there, negative 11, 3x. So x equals to negative 11 over 3. Okay, wow, two of you, very quick, and then sounds like you don't have any problem with the algebra as well. It's a good thing, and it's very important also. Algebra, where you learn in Form 2 or Form 1, is actually carry forwards, and then you will use it a lot in MS and also mathematics. So it is very good if your algebra is very strong. Okay, so far today we have learned about a few things here. Okay, so very quick recap. Okay, from the very beginning, we learned about the type of relation, what is functions, and also the type of relation here. Okay, we have these 4 types of relation: one-to-one, many-to-one, one-to-many, and many-to-many. Okay, if it is to one, that means it produces one product only. No matter how many ingredients you have, you produce one product only, then it will be a function. If you product 2 product, okay, at the same time, then it is not a function. But the proper way to say it is the relation is a function because the object has only one image. Okay, the relation is not a function because the object has more than one image. Okay, if we have a graph, then we do the vertical line test. If it passes through or it intersects the graph at one point only, that means it is a function. If it intersects the points, the graph at 2 points, that means it is not a function. Then we learn also how do we write the set notation. That means in the group, this one is set notation. And then we learn also how to write the domain, codomain, and range. Okay, by referring to the graph like this, the discrete graph and also the continuous graph. Next week, we will try to draw the continuous graph and then write the domain and the codomain, something like this one. Okay, this one we will do it next week. Okay, we will try to draw, sketch a graph, and then we write the domain, codomain, range, and all those things. This one came up quite often also, quite common also in SPM, and then a lot of students cannot do. So yeah, next week may be difficult a bit, but I don't think will be a problem for two of you. Okay, and then next part we learn how to count, how to find the image, and how to find the object. So basically that's it for what we learned today. Okay, so far got any problem or not? No, okay, if there's no problem, then I hope you can understand with these lessons lah. If you have any question, then please drop me a message or what. I don't know whether you got my number or not. Okay, so if you enroll to the class, normally you will have my number, and then you can drop me a message, okay, in WhatsApp. If you have any questions, then you can ask. If you have any questions from your schoolworks, you can ask also. Okay, but I may not be reply you immediately lah, but I reply on the day as well. Okay, so if there's no questions, then we can stop here and I'll see you next week. Thank you, class. Bye-bye.